Hello students, today's topic is area of a ring. Now let us take this figure. Observe that figure. In a park, a circular path is laid as shown in the given figure. Its outer and inner circles are concentric. Let us find the area of this circular path. The area of the circular path is difference of area of the outer circle and inner circle. If we say the radius of the outer circle is capital R and the inner circle is small r, then area of the circular path is simply area of outer circle minus area of the inner circle. So area of outer circle is taken as pi into capital R square minus, and in the same way area of inner circle is taken as pi into small r square. So pi taken outside, pi is a common, then pi into capital R square minus small r square. Then only we get that shaded region which is our required area. Hence, the area of the circular path or area of the ring is equal to pi into capital R square minus small r square, or pi into capital R plus small r into capital R minus small r. So, already we denote capital R and small r are the radii of outer circle and inner circle respectively. Okay, I hope you understand this formula. Now, let us observe sum. Here is very simple sum. Observe the adjacent figure and it shows two circles with the same center. The radius of the larger circle is 10 cm and the radius of the smaller circle is 4 cm. Find number 1 the area of the larger circle, and second one the area of the smaller circle, and third one the shaded area between the two circles. Here we have to take pi value 3.14. Let us see one by one. Now here radius of the larger circle is 10 cm. So area of the larger circle is simply we can take pi into capital R square. Then by substituting pi value 3.14, r square nothing but 10 into 10, that is equal to 3.14 into 100. Simply we get 314 centimeter square. That is our area of larger circle, that is outside circle. Now again see the radius of the smaller circle is 4 centimeter. Then the area of the smaller circle is simply pi into small r square. Then 3.14 into 4 into 4, we get simply 50.24 centimeter square. Now we need actual area. What is that? Area of the shaded region, that is called as area of the circular path. That is can be found out by simply subtraction of the area of the larger circle and area of the smaller circle. That is area of the larger circle minus area of the smaller circle. Then we get 314 minus 50.24 centimeter square. Then the result we get 263.76 centimeter square. Okay, children, this is a very small sum and important. And next, length of the arc. Okay, length of the arc, very important concept. Length of the arc. Observe the following circles, and we have the table also. Just we have to fill up this one. First, observe the each and every figure in this. We have length of the arc. Observe the following circles, and we have a table up below that one, below these figures. So now complete the table also. Now observe the each and every figure. Here the first figure is the arc, length of the arc 2 pi r taken. That is the complete circle, which makes an angle at center 360 degrees. Okay, and the next one is a half circle, as you all know, that is this arc is also substance in our length at center is 180 degrees. And next it is a 1/4 of arc, simply quarter arc. This is also a makes or substance an angle 90 degrees at the center. Now it is a 45 degrees, that is the half of the 90. Again this arc also subtends an angle at the center 45 degrees. Now again here the small length of the arc L, that is also just subtends an angle of x degree at the center. And in general I am taking again 60 degrees, that some length of the arc subtends an angle at the center. Now we need to find length of the arc, that is how to find the actual formula of the length of the arc. Take a table here. See this in figure, we have first figure, that is first column angle, second column length of the arc, third column relation between angle and length of the arc. So the first angle is 360 degrees already we saw that the length of the arc is 2 pi r, that is simply circumference of a circle. That length of the arc, that full circle, subtend an angle 360 degree at the center. Then we can have a relation here, what it is 360 degree by 360 degree into 2 pi r. That is we are taking full 360 degree at the center. That's why we are writing it as 360 by 360 into 2 pi. That is, we are taking the full part of that circle. Now 180 degrees. So whenever 180 degrees, the length of the arc becomes pi r. So here also you can write 180 by 360 into 2 pi r. That is 180 by 360 is a part of that whole part. That is multiplied to that of the 2 pi r. Why? Because the total length means total circumference of the circumference of circle is always taken as 2 pi r. So we have to take the fractions one by one. Okay, children. Here pi r is of length of the semicircle, and 180 degrees is actually that arc makes an angle with the center. That is, we are just obtaining a relation between the angle and the length of arc. Just see carefully. Now the next one is 90 degrees, and we are getting pi r by 2. How? Simply you can write 90 by 360 into 2 pi r. Then only we get pi r by 2. Okay, children. And the next, here pi r by 4. Just check it out. Here again 45 by 360 into 2 pi r will get automatically pi r by 2. How? By 9 table you can cut it off. 9 5s are 9 40s are, again 5 table 5 1s are 5 8s are, and 2 and 8 gets cancelled, we get pi r by 4. Okay, children, that is pi r by 4. And next, whenever you take the some x degree with the length of the arc L, then we will get simply x degree by 360 into 2 pi r. That is our required formula. So that's the length of the arc is simply x degree by 360 into 2 pi r. Just remember that formula. Now whenever 60 degrees, then automatically you can write pi r by 3. How? 60 by 360 into 2 pi r, that is equal to pi r by 3. Okay, children. Now let us discuss again. From the above observations, the length of the arc of a sector is L is x by 360 into pi r square, where r is the radius of the circle and x is the angle subtended by an arc of the sector at the center of the circle. So then we can get easily length of the arc of a sector L is simply 2 pi r by L is equal to 360 by x degree. Okay, children. Here x degree is a part of 360, and it is proportional to the 2 pi r by L. 2 pi r L is again the 2 pi r, part of a 2 pi r. So we are existing a proportionality in between the lengths and the angles. That means we are existing a relation in between the length of the arc and the length of the arc of a sector and angle of a sector. Okay, children, I hope you just understand very well this topic. Then we will write it as L is equal to x by 360 into 2 pi r. Now again, area of sector, we know that part of a circle bounded by 2 radii and an arc is called a sector. Okay, what is a sector? Sector is a part of a circle bounded by 2 radii and an arc is called a sector. Now, what is the area of a circle with radius or pi r square? Angles subtended by the arc of the sector, arc of the sector at the center is what? X degree. So area of a sector and its angle are in the direct proportion. So that's why area of a sector is to area of a circle is equal to x degree is to 360 degree. Okay, children. By that way we can write the area of a sector is equal to x by 360 into area of a circle. Okay. So till now we learned two formulas. One is area of a sector, another is the length of the arc. Okay. Now let us take hence the area of a sector OAB can be written as it's also represented in other terms also. Okay, see that one how x by 360 into pi r square, that pi r square can be written as pi r into r, then that r again multiplied by 2, multiplying dividing by 2, that is pi r into 2r by 2. Then we can rearrange this x by 360 into 2 pi r into r by 2. So now we got it as x by 360 into 2 pi r is L. Now L into R by 2. So the other formula for, in other terms, the area of a sector is equal to LR by 2, where L is the length of the arc. Now see the important sums here. We have here two sums. Find the area of a shaded region. So area of the shaded region here simply area of the square with side 21 minus area of a circle with diameter 21. Okay, children, that is here the circle is completely inside of the square and it also touches the sides of square. Now we can say easily the diameter of the circle is must be equal to the side of a square. Okay, children, by that way we can get the diameter of a circle. Okay, now so the diameter of circle is 21 centimeter, 21 meter. The radius of the circle is simply diameter by 2, that is 21 by 2. We will get simply 10.5. Half of the 21 is simply 10.5. Area of a shaded region. Now we required area is simply you have to subtract the area of a circle from the area of a square. So area of a square is formula side into side, that's why S into S minus area of a circle formula pi r square, that's why 22 by 7 into 21 by 2 into 21 by 2. Then on simplification we get 21 and 21 441 minus this all fractions division or multiplication we get 346.5. On subtraction you get 94.5 meter square. Okay. Now in other sum, area of a shaded region. So in other sum we have a square and in that one at four corners we have the four squares. That means each at four corners we have the four sectors. That means we have the four quadrants. Okay, so area of a that shaded region can be found out by simply again subtraction of that four areas of sectors from the area of the square. Then now here we have area of a square with side 21 is 21 minus 4 into 90 by 360 into 20 by 7 into 21 by 2 into 21 by 2. On simplification we get simply area of a shaded region is simply area of a square with side 21 minus 4 into area of a sector. Now 21 into 21 minus 4 into 90 by 360 into 20 by 7 into 21 by 2 into 21 by 2 meter square. The diameter is 21, then the radius is simply 21 by 2 as you all know. Now again 21 and 21 441 minus. So here we have actually 4 sectors, that's why 4 into 1 by 4 into 20 by 7 into 21 by 2 into 21 by 2. So how can we get here 1 by 4? Simply that each corner angle is 90 degrees. So 90 by 360 nothing but 91 the 94, that we will get simply 1 by 4. So pi value you know 22 by 7, that r value is 21 by 2. That's why you can write it as 21 by 2 into 21 by 2. Okay. Now on simplification we get 441 minus 346.5 meters square. Then the final answer is 94.5 meters square. Now let us see next one, very important. A rectangular acrylic sheet is 36 centimeter by 25 centimeter. That is we have here, yes, in this type of acrylic sheet we have length 36 and breadth 25. From 8 to 56 buttons each of diameter 3.5 centimeter have been cut out. Find the area of the remaining sheet. That means on acrylic sheet 56 buttons are located. Then we have to remove the buttons which are in the circular shape. So we have to find the area of the remaining sheet. That means here also you just find out first of all the area of a sheet and then area of each button, and after getting the area of each button which is a area of circle and then which is having a area of a circle, then multiply that each that area of the circle by 56, then we get the areas of the 56 circular buttons. Then subtract that 56 circular button areas from the area of the rectangle. Now let us see how it is. Now length of the sheet 36 centimeter, breadth of the sheet 25. Now diameter of button is given 3.5 centimeter. Then the area of remaining sheet is simply area of sheet is equal to area of rectangle, that is a length into breadth 36 into 25, that is 900. We are doing step by step here. Now area of each button is area of a circle pi r square. Now that is 22 by 7 into 3.5 by 2 into 3.5 by 2. Then the area of the 56 buttons, simply 56 into 22 by 7 into 3.5 by 2 into 3.5 by 2. then we'll get 8 into 22 into 3.5 by 2, nothing but 1.175. 3.5 by 2 we can repeat it, so that we can write it as 1.175, that is equal to 538.51. So we can write approximately 539. Now the required area is area of rectangle minus area of 56 buttons. So now we get 900 minus 539, then we get 361. Okay, like this we can get now. Yes, one more important, it is also just like before some only. Find the area of circle inscribed in a square of side 28 centimeters. Okay, children. Here also, see this, the circle is inscribed. That means the circle is touches the four sides of a square inside. So that's why diameter of that circle must be equal to the side of a square, which is 28 centimeter. Now let us solve this one. Given diameter is 28, the radius is equal to diameter by 2, that is 28 by 2, we will get 14 centimeter. Then area of a circle is simply pi r square, then 22 by 7 into 14 into 14, then 3.14 into 14, 14 is 196. So that's why here on multiplication we get 615.44, 615.44 centimeter square. Okay, very easy sum. Now let us see this, children. Find the area of the shaded region each of the following figures. We have here two figures. First observe the first figure. Here we have the square, and each side of square is surrounded by a semicircle. That means we have on four sides of a circle we have with four semicircles. Now here measurement, see this. So measurement of the square is d, and then he has given one hint here, simply the total length, that is the left and right side points on the edge points, the distance between the end points is given as 42. That means here d plus, we have to add d by 2 to d. Why? Here d by 2 is the radius of that each semicircle. Okay, children. Why? Because here d is the diameter of the semicircle, then radius is d by 2. We need either side of the d radius of the semicircle. Then whenever you add the two radii of the semicircles to d, then we get that 42. That means d by 2 plus d by 2 is equal to 42. Okay. Now on simplification we get d is equal to 21. d by 2 plus d by 2, just 2d by 2, 2 gets cancelled, then we get d. We should add d to that one, d plus d, 2d is equal to 42, then d is equal to 42 by 2, then that is 21. That is side of a square we get what it is, 21 centimeters. Okay. Now let us see the solution of this first figure. Now see this diameter is 21, we got radius of a circle is simply diameter by 2, 21 by 2, then we get 10.5. Now we need to get area of semicircle. First of all, first semicircle, that is we know 1 by 2 into pi r square. Area of a full circle is pi r square. Area of the semicircle means half of the circle, simply you can half of it, that is 1 by 2 into pi r square. You can just simply remember like that. Now on simplification, that is by substitution all these things, 1 by 2 into 22 by 7 into r value 10.5, so it is repeated 2 times, as by 10.5 and 10.5. Now 11 by 7 into 1 cancellation by 2 table, we can get 11 by 7 into 1, 10.5 into 10.5 is 110.25, and again on division of 7 or by cancellation with 7 we get 15.75, that is 110.25 by 7, nothing but 15.75. Now on multiplication, 11 into 15.75 we get 173.25. Okay. Now after getting there, we have to multiply that with the, okay. Now again here we have the another figure. Diameter d1 21, radius of the circle simply diameter by 2, 21 by 2, and then here diameter d2 is actually it is 10.5, then the radius of the circle is diameter by 2, 10.5 by 2, simply 5.25. Then area of a circle 1 is pi capital R square, so that is 22 by 7 into 10.5 into 10.5. See this, children, here the biggest circle is having the 10.5 and the smallest circle is having the 10.5. Biggest circle means below the line, that is biggest semicircle. Actually it is having the diameter 21, and a semicircle, small semicircle, having the diameter 10.5. So that's why we are taking the capital D1 to the top of the below circle, and small d2, capital D2 to the top of the above circle, above small semicircle. Okay, I hope you understand this figure. Now you have to find actually the area of the circle only. Why? Because here on bottom, that is circle, semicircle below the line is simply a semicircle, half of the circle, and above is also same, that is also a half of the semicircle. By combining these two, we'll get what? Again a full circle. That is, here they are asking indirectly area of a ring. That means we have to separately find out the outer area, that is outside area of circle, and then after getting that, you just find the area of the inner circle. Here also observe the small semicircles are like either side of the line. So by combining those two, we get back same thing, area of the small circle. Okay. Now first we find the area of the circle 1 pi into capital R square. Then we get 22 by 7 into 10.5 into 10.5. 10.5 is the radius of the biggest circle. So by cancellation or calculation, we get 22 by 7 into 110.25. That is simply we get 22 into 15.75, and cancellation of 110.25 by 7. Then on simplification, we get 346.5. This is the area of the largest circle, that is circle 1. Now area of circle 2, that is small circle. By applying pi r square, we get 22 by 7 into 5.25 into 5.25. So then on multiplication, we get 22 into 3.9375. However, we get 86.625. Now we need to get shaded region. So area of the circle 1 minus area of the circle 2. Then we get 346.5 minus 86.625, that is equal to 259.875. Now let us see one more important sum. The adjacent figure consists of the 4 small semicircles of equal radii and 2 big semicircles of equal radii. Find the area of the shaded region. So just observe the figure carefully and note down that markings. Okay, that is, you must note down that markings also. That is A1, A2, B1, B2, C1, C2. So here A1, A2 are the bigger semicircles. B1, B2 and C1, C2 are the smaller semicircles. Those are 4 and these two are 2. That only they are given. But big semicircles having the equal radii 42 and 42. Okay. So see the first of all this one. From figure we can observe that, just carefully observe that A1 minus C1 plus B1. That means here C1 is unshaded. That's why to get the A1 shaded region, just you have to subtract the C1. Then automatically we have the B1 is also shaded. So we have add that B1 to that A1 minus C1. Then we get the shaded region of the first part. But it is again equal to area of the semicircle. Actually what it is? Area of the semicircle. Okay, that unshaded is subtracting, shaded is the adding. So overall we will get one big semicircle. Okay, now again area of the semicircle and hence the required area is here. Again that side also A2 minus C2 plus B2. Okay, above the line we have A2 minus C2. Why? Because A2 is actually shaded region, C2 is unshaded. So that's why to get that shaded region we have to subtract the A2 minus C2. But again we have the B2 in that region, so which is a shaded. So we should add that one. So A2 minus C2 plus B2. Here also we are getting what? A big semicircle. So hence we have to get the 2 areas of semicircle. That's why I am writing hence required area is equal to 2 into area of semicircle. Just that is the magic. By understanding the figure only you will get easy solution. Okay. Now see this. Given diameter is equal to 42 centimeters, radius S is equal to D by 2, that is 42 by 2 is equal to 21, radius of 2 that is 21 by 2, 10.5. That is no need actually. If you need that C1 and C2, B1 and B2, you just calculate, add them and subtract them. From which A1. And after getting that whole result, we should add, we will get the same result. Okay. So no need to worry that one. Simply you have to find out you have to write this right side information first of all, and then go through the solution. Okay, area of the required shaded region is equal to, simply you get 1 by 2 into pi into r square into 2. So here 2 gets cancelled, 22 by 7 into pi value 22 by 7 into 21 into 21, r value 21, that's why 21 21. So on simplification, 7 1 the 7 3 we get 3 in 21 63, so 22 into 63. Now we required area is shaded region is 1386 centimeter square. I hope you understand this one. Next, again same type. Adjacent figure consists of the 4 half circles and 2 quarter circles. Okay children, by given that OA is equal to OB is equal to OC equal to OD equal to 14 centimeters. Indirectly they give again diameter only. Now observe that we have with the AC arc 1 quadrant arc, and with BD arc other quadrant arc, 2 quadrant arcs, quarter arc circles, that means quadrants. And next 4 semicircles, 2 shaded and 2 unshaded. 2 shaded means OD, with OD and OC shaded, with OA and OB unshaded. So anyhow, we have to again find the area of the shade by the same magic. So now see this. Yes. Now area of the quadrant A1 is equal to, actually the 1 by 4 into pi r square. So given radius is 14 centimeter. So first of all you have to find out A1 as equal to the 154, and then given diameter is 14 centimeter, radius is d by 2, that is 7. That is we need here actually area of the quadrant and area of the semicircle. From that only the magic will be begin. Okay, area of the semicircle is equal to 1 by 2 into pi r square, then 1 by 2 into 20 by 7 into 7 into 7, that is equal to 77. So area of the quadrant is 154, area of the semicircle is 77. But we need area of the first area 1, that can be found out by area of the quadrant minus area of the semicircle. Why? Here in the first quadrant, actually if it is also that semicircle is also shaded, we get easily area of quadrant, but along the AC some part is unshaded, that is the small semicircle is unshaded, that only we have to subtract. That's why we have to subtract that area of semicircle from the area of the quadrant. Then what do we get? Yes, 154 minus 77. In the same way, shaded region, actually that shaded region is where A1 and A2. Okay, A1 A2 are the same now, that's why we are writing A1. That's why here we solved only A1. Then A2 no need, just you can write as it is value. A1 is equal to A2 here, and we should add A1 A2 and B1 B2. Okay, so A1 A2 B1 B2. A1 A2 are the area of quadrant minus area of the semicircle. Okay, and B1 B2 are the what? Areas of the direct semicircles. So that's why you can add all the things which are all equal to 77. Okay, 77 plus 77 plus 77 plus 77, then we get 308 centimeters square. Now again very important sum. In adjacent figure, A, B, C and D are centers of the equal circles which touches externally in face, and ABCD is a square of side 7 centimeter. Find the area of the shaded region. So children, this type of structure you can observe while playing with the carom board. So whenever you look at 4 coins or 4 strikers like this, you will get this type of figure. No? So here we need to find the shaded region. Okay, whenever you keep the 4 coins like this, we will get a region in between them, okay, or among them. So now we have to find that area shaded region. So by observing this figure, we just at the corners we have 4 sectors. That is, at the corners of the square we have the 4 sectors. So we have to subtract that areas of 4 sectors from the area of a square. Very easy. See this. Now area of a quadrant A4 is equal to 1 by 4 into pi r square. That is, we are finding out the area of a sector first of all. That is also called as quadrant. Why quadrant? At each corner we know that angle of square is 90 degrees. So that's why 90 by 360 into pi r square will get 1 by 4 into pi r square. Now radius is equal to simply 3.5. Now 1 by 4 into 22 by 7 into 3.5 into 3.5. So then 1 by 4 into 22 by 7 into 3.5 and 3.5, 12.25. On simplification we get 5.5 into 1.75. So the product is 9.625. That is the each quadrant at A is equal to at B is equal to at C is equal to D. That is each quadrant area at A, at B, at C and at D is equal to 9.625. But those are 4. That's why we have to multiply that with 4. Okay, so directly here we can do shaded region is equal to area of a square minus AS is represents the area of a square minus 4 into A4. A4 represents the area of the each quadrant. So we will get area of a square is simply 77. Why? Because each square area side is given. Each side of a square is 7. So 77 minus 4 into 9.625. By simplification we get 49 minus 38.5. Then on subtraction we get 10.5 centimeter square. Okay, children. Now one more important sum. The area of a equilateral triangle is 49 root 3 centimeter square. Taking each angular point as a center, a circle is described with radius equal to the half of the length of the side of triangle as shown in the figure. Okay, children. So find the area of the portion in the triangle not included in the circles. Okay, in before figure we take 4 points. Here you just take the 3 points and you can easily understand. Okay, now here first of all we have to find the side of a equilateral triangle. Okay, why? Because they are given only the area of a triangle. So let us see step by step. Now area of equilateral triangle is given as 49 root 3. We know that the formula root 3 by 4 into a square, children. That is not a2, root 3 by 4 into a square. Okay, that is a nothing but side of a equilateral triangle. So root 3 by 4 into a square is equal to 49 root 3. On simplification we get a square is equal to 49 into root 3 by root 3 into 4. Actually 49 into root 3 into 4 by root 3. Whenever you take root 3 by 4 to that side, we get 4 by root 3. You know that one. So root 3 root 3 gets cancelled. We get 49 into 4, that is 196. And then we know that a square is equal to 196, nothing but 14 into 14. Otherwise you can write a into square root of 196, that is square root of 14 into 14. Then a value is 14. Okay, like that also you can do. Then the radius is simply a by 2, that is 14 by 2, 7. Why? Because we need the quadrant, not quadrant, the area of the sector. Why? Because the angle is here 60 degrees. So area of a sector is x by 360 into pi r square. So just find out the one sector area, that is 60 by 360 into 22 by 7 into 7 into 7. Then we get 77 by 3, that is 25.66. Now the required area, that is we need to get that area is equal to 49 root 3 minus 3 into 25.66. Then 49 into root 3 value 1.732. Just remember that one, otherwise they will give in the question. So minus 3 into 25.66. 25.66 into 3 is 76.98. Then the final answer is 84.868 minus 76.98 is equal to 7.888 centimeter square. Okay, children, like this you just do all these sums, okay, on a notebook and practice them regularly. Okay, thank you.